Hello there, it's Alana Tuckey, and I'm going to finish up the lecture for section 7.1. So if you recall, we've learned a whole bunch of things about how A, H, and K affect the graph of a parabola. And also remember that the vertex has to be HK, and that H is always a little bit weird because it seems backwards. And then K works just like you expect. Okay, so what we're going to do is we're going to look here and try to figure out what all our values are. So for vertex, whether it opens up or down, shifts up or down, shifts left and right. And actually, I added in a little column right here. You're going to need it in order to be able to answer this question. So I kind of threw in an extra column. You can kind of put it in the margin of your paper somewhere. Okay, so let's talk about the vertex. The vertex, remember, is h comma k, but h always seems backwards. So when you look in there, it looks like it's -7, but that means that h is +7 and k is just like you think it would be. So it looks like -5 and it is -5. So there's your vertex. Let's keep going with the vertices, shall we? Vertices. All right, so let's go to the next one. Oops. There we go. All right, so h is backwards. So it looks like +1. That means it's -1. K is just like you expect, -2. Done with that one. Now here, it looks like +4 inside that parentheses. So that means it's -4. And then K, we don't have a number added on to the end. So it must be 0. All right, now what about this one? We don't have a number inside the parentheses on this last one. So that means that H is actually 0, right? There isn't an H. There's no number in parentheses like there is for these other three. And K is 6 because you're adding on a 6 at the end. So there's that. All right, so there's how to find the vertices of those four graphs. Now, are they opening up or down? Well, remember, opens up and opens down depends on your sign of your A in front. So if A is negative, it's going to open downward. If A is positive, it's going to open upward. So this one has A is +0.3, so that opens up. Hold on. There we go. Okay, then the next one has a -4 in front, so that opens down. Then up because of +2. Then down because of -1/4. All right, so the opens up and down is determined by plus or minus sign in the front. +3 or 0.3 opens up, -4 opens down. Now, shifting the graph up and down, that's based off of K, the number in the back. So the first one is down 5. You can tell because the vertex is down -5. So down 5. The next one's down 2. The next one isn't up or down at all. So it's neither because we're not adding on a K at the end. So it's 0. It hasn't been shifted up or down. It's opening up, but it hasn't been shifted up, if that makes sense. And this one is up 6 because +6 at the back. All right, now what about left or right? Well, it helps if you've already figured out your vertex because your vertex will help you figure this out. You say, okay, it's moving to the right 7 because H is +7. So right 7. This one's left 1. If you just figure out your H correctly the first time, you're set. This one's left 4. And this one isn't left or right at all because there's no plus or minus inside the parentheses there. So it's neither. All right, so let's go down here and look at which was the narrowest of the graphs, f of x, g of x, h of x, or k of x. Well, that would be your narrowness is dependent upon the bigger your a is, the absolute value of a, for example. So of those four numbers, which has the largest absolute value? Well, that would be g of x, right? Because it has the largest a value. No, it's the absolute value of a. It's irrelevant that it was a -4. All that matters is that it's the magnitude of the number, right? If you take the absolute value of it, then it's the largest. All right, which graph has the widest graph? Well, let me copy and paste that. The widest graph would go to k of x because k of x has the smallest number, right? K of x because it has the smallest value. And I can tell it's the smallest value because I know 0.25 is equal to 1/4, and 0.25 is smaller than 0.3. To make comparisons, sometimes you might have to change from fraction to decimal. which I did in this case. All right, now we get to the intercepts. And so what I want to do is kind of make a quick sketch here. This one has been moved right and down, and then it's opening upward like that. So let me grab a quick sketch of that graph. Hold on. It would look like this, right? You moved right and downward, but you're opening up. So it's going to have two intercepts. All right, now I copied and pasted that graph just to help myself, but the rest aren't going to work that way. So we need to have it moved left and down and open down. So let me go grab a picture of that. There we go. It's teeny tiny, but you get the idea. It's going to be left and down, so it's going to be and pointing downward. See how it's pointing down? So that means you're never going to have any. So you're never going to hit that x-axis because it's going to keep going down, down, down. All right, the next one's been moved left, but not up at all. And it's facing up. All right, that looks like this. So it just touches the axis and then drifts off. As a matter of fact, I can show you a better picture right here so you can see what it looks like. It just touches right there and goes away. So that only has one intercept. All right, and then the last one has been shifted up, but it's facing downward. Hold on. That would look like this, right? So it's shifted up, but it's facing downward. Or if you want to see a better picture, right here, it'll look like that. Okay, so if that's the case, then you have two intercepts again. You've got one on the left side, one on the right side. So it's sort of a trick question, not really, but there's two graphs that have two x-intercepts. The first one, f of x, and the last one, k of x. F of x and k of x. Beautiful. All right, we're done with that problem now. And again, I added in that last column, but it's useful stuff to know. Just to be able to draw a quick sketch and figure out how many intercepts you have is a very nice skill to have. All right, so now that we know how to do this, we're going to graph the following by placing the vertex in the middle of the table and then finding a couple points on either side. So when you look at this, you see how it looks like a +2. That means the vertex is actually -2, -4. All right, now we're going to fit some points on either side of it. So -3, -4, -1, and 0. And actually, I'd like to fit in 1 here and -5 here. So add in a row or two, and we'll throw those in for good measure. One sec. All right, there we go. Now, there are a lot of ways you can help yourself to find these values, but the easiest thing would just be to type it into the calculator and have the calculator help you. So let's do that. So we go to y equals, clear out the old equation, and write -3 parentheses, what was it? X plus 2, x plus 2, close parentheses, squared buttons over there on the left, take away 4, if I'm not mistaken. Yep. Nope, not 44. That's not good. There we go. Enter. All right, I don't really need the graph from the calculator. What I want is the table. And I don't need all these values over here. I'm going to have to scroll up to find 0. As a matter of fact, I'm going to go to Table Set, which is second window. I'm going to make my table start where I want it to start, which is -5. And then that way when I go to the table, I'll see exactly what I want. -5 goes to -31. -4 goes to -16. -3 goes to -7. -2 goes to -4. Oh, see the symmetry there? -2, -4 is the vertex. You can see it. So then it goes 16 and 31 again. All right, so I'm going to go fill those values in my table. Right over here. Hold on. All right, now I'm going to use those values to graph this. So I'm going to graph these points on this grid, and then I'm going to connect the dots. So hold on. And there it is. Beautiful. All right, so now what's the domain of g of x? Well, that's -infinity to infinity because the graph never stops going left and right. It goes forever to the left, forever to the right. You can see it in the table when you graph it because it just keeps going and going and going and going and going and going forever. Oops, right here. Up, 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 forever, right? So it's not changing at all, right? It's never stopping, right? So it goes forever to the left, forever to the right, so -infinity to infinity. The range, remember, is down to up. So the graph is plummeting to negative values. So -infinity still, but it gets all the way up to something else. It gets to -4, right? That's the highest your y value can go. So what we need is negative infinity, because it goes forever in the downward direction, comma -4, but it actually reaches -4, so you get to put a bracket there, right? You hit -4 right there. Okay, so negative infinity to infinity for the domain. That's left to right. Range is down to up, so it goes forever downwards, that's negative infinity, and it stops at -4 on the upward side. All right, we're done with that problem. Let's move on to the last one, which is just understanding A, H, and K from a different angle. So you're trying to figure out, is A positive, is H positive, and is K positive or negative? So this one, you can see this graph is opening upward. So that means that A is positive. It deserves a plus sign. There we go. I made it easier to type it. Okay, so A is positive because it's opening up. Let's keep going with A, actually. This one's positive because it's opening up as well, right? So since it opens upward, it's positive. Okay, then what about down here? This one is negative, right? Because it's opening downward. And this one's also negative because it's opening downward. There we go. All right, now what about H? H is the weird one. But it's only weird in the formula. So it's going to work exactly like you think. If your graph is moved to the right, then H is positive. So this graph was definitely shifted to right because the normal vertex is at the origin. So we've been moved to the right, so H is positive. Let's see, what about this one? Well, this one hasn't been moved at all. So this is 0, right? It hasn't been moved left or right. It's only been moved up. So that would be a 0 value there. There we go. Now what about this one? Oh, this has been moved to the right as well, so that's positive. But this one over here has been moved to the left, so this one's negative. All right, now let's go back up. K. K is up or down. So this graph has been moved up, right? Because the normal vertex is at the origin. So since it's been moved up, that gets a positive sign. If I can make it work. There we go. Okay, now what about this one? Well, this one's also been shifted upwards. So that's also a positive K. This one's been shifted down, right? Because the origin, the vertex, excuse me, is from the origin downwards. So that's negative. So I'm going to put a negative sign there. And this one hasn't been moved up or down at all. So that's 0. I'm going to put 0 in there, right? Because it hasn't been shifted down. It's still on the x-axis. All right, now which of these graphs had this largest A, absolute value of A? Well, that's letter D. Letter D, because it's the steepest parabola, right? It's the steepest, narrowest graph. Which one had the smallest? Well, that's C. C is the widest. Shallowest, widest parabola. All right, we're done with section 7.1. I'll see you back here for 7.2.